Welcome into this week's episode of Weather Extra. I'm First Alert Meteorologist Jillian Johnson. For us in Central Texas, last week we experienced some of the hottest temperatures that we've faced so far this year. Much of the East Coast was dealing with flooding tropical rains from Debbie. We get Weather Extra kicked off this week by taking a look back at the fourth named storm, the Atlantic hurricane season. Debbie was the second hurricane of the 2024 Atlantic hurricane season and made landfall as a Category 1 storm across the Big Bend region of Florida early Monday morning with maximum winds of 80 miles per hour. The major threat from Debbie was the torrential rain the storm would go on to produce. Across many Florida cities, more than a foot of rain fell, leaving local first responders rescuing hundreds as water rose into homes. Debbie would go on to claim the lives of at least 5 people in the state of Florida. Although the number one concern with this storm was the life-threatening rainfall totals, Debbie also brought damaging winds and high storm surge as well. As Debbie moved inland across the Sunshine State, the storm would weaken back down to tropical storm strength and remained a tropical storm as it crossed over into the state of Georgia on Tuesday. This storm was a very slow-moving storm and managed to linger over coastal Georgia and the Carolinas into the middle of last week, which increased the flooding potential as the heavy rain continued falling out of the sky. The National Hurricane Center warned of a life-threatening flood event as Debbie continued to drench numerous historic southern United States cities and towns. Savannah, Georgia would see over 10 inches of rainfall, while Charleston, South Carolina would see over a foot. Here's a look at some of the flooding that Debbie caused across the southeastern United States last week. Debbie lingered along the southeastern U.S. and would eventually re-emerge back into the Atlantic Ocean by the middle of the week. The warm waters in the Atlantic allowed Debbie to regain strength and eventually make another landfall early Thursday morning. Debbie's second landfall occurred near Bulls Bay, South Carolina. The storm had maximum winds of 50 miles per hour. As the storm slowly moved up the eastern seaboard, it continued to unleash a dangerous flood and tornado event for millions of Americans. In fact, on Thursday, 22 million people were under weather alerts. Numerous tornadoes would occur across parts of the Carolinas and the mid-Atlantic states midweek into Thursday. One man lost his life in North Carolina as a twister caused his home to collapse. Another man would lose his life as a tree fell on top of his home. Debbie would drop more than 14 inches of rain in parts of southeastern North Carolina, causing flash flooding across the state as the storm crawled up the I-95 corridor. Thankfully, Debbie tracked northeast after its second landfall, pulling further away from the Atlantic Ocean on Thursday, allowing the storm to lose strength, transitioning into a post-tropical storm. But unfortunately, Debbie would go on to cause additional rounds of severe weather and life-threatening flooding across the northeast and through the New England states on Friday and into the weekend before the storm would move into Canada. Although Debbie was not the strongest hurricane of the season, it will definitely go down in the history books as this storm caused widespread damage up and down the East Coast. Forecasters are still calling for an extremely active hurricane season. For an update on how things are looking out in the tropics and how that could impact our weather later in the year, we bring in First Alert meteorologist Sean Bellafury. Sean.
The 2024 hurricane season, compared to years past, has kind of been off to a slow start with only 4 named storms so far. But of course, we had Beryl, a Category 5 monster, and Debbie, which lashed the mid-Atlantic this past week. But we are still not yet at that peak of hurricane season, fast approaching it. And as you take a look at tropical satellite, I do want to point out that there are a couple of different areas to watch. One area of showers and thunderstorms moving across the Atlantic, the main development region, is something to watch. And notice all of these thunderstorms back over Africa. These are the seeds to what could potentially be more tropical storms as we push deeper and deeper into the month of August. The main development region is warming up with sea surface temperatures 80 degrees plus pretty much basin wide. That 80-degree threshold is pretty much what you need for tropical storm development. And even though we look at the Atlantic basin for the Atlantic storms, we actually have to take a look at the Pacific basin for something else. Notice these cooler temperatures showing up in the Pacific. That is what's called the El Nino region, or the ENSO region, where we look to see if we're going to be going into an El Nino or a La Nina. And since we're starting to see cooler than normal sea surface temperatures, we are about to kick into gear another La Nina season. Now, La Nina is not officially yet declared across the globe. globe. El Nino really peaking during the course of last year, but now a sharp decline in those sea surface temperatures is getting us closer and closer to a La Nina. So even though it will potentially supercharge the hurricane season, we may not actually start to feel the influence of La Nina across the tropical Atlantic into the last part of the 2024 season, and of course as we head into winter. Now, a La Nina winter in central Texas is something that we've experienced. 2020, 21, 22, all were La Nina winters. Now, typically during a La Nina winter, the jet stream, the polar jet stream, is a bit more variable, and on average central Texas is warmer and drier than normal. And the forecast for December, January and February coming from the Climate Prediction Center, a good chance of warmer than normal temperatures, a very good chance of below normal precipitation. But as far as those temperatures go, it's not going to be warm all winter long. We frequently get big shots of cold air during a La Nina winter. Reporting in the studio, Sean Bellafiore, KWTX News 10.
And more severe weather hit the Northeast earlier in the week before Debbie arrived. A video shows a waterspout forming over the Niagara River before moving onshore in Buffalo's downtown area. The National Weather Service in Buffalo, New York, confirmed an EF1 tornado struck the city on Monday with estimated peak winds of 90 miles per hour. The twister then kicked up debris and barreled toward a nursing home building where roof air conditioners units were ripped off. Another structure's roofing material was later found 2 blocks away. The tornado also overturned at least 2 cars. Fire officials said only minor injuries were reported at the nursing home. And another major weather story we've continued to follow over the past few weeks has been the devastating wildfires that continue to burn hundreds of thousands of acres across the western half of the nation. Throughout the last week, there were 93 large active wildfires nationwide. There were 10 new large fires that popped up last week alone. So far this year, wildfires have burned over 2.4 million acres across the U.S. The states with the highest amounts of fires ongoing are Oregon with nearly 30 active fires, Idaho with over a dozen, and California, Washington, and Arizona with 9. 17 of the 93 fires last week required Americans to evacuate. Unfortunately, weather conditions for the firefighters fighting those blazes are not ideal, and officials worry these fires will continue to grow in size as strong winds and above normal temperatures remain in the forecast. Well, earthquakes have been shaking many West Texas towns the last few weeks, and coming up after the break, we hear from one local resident who is ready to leave town as the tremors remain persistent. Welcome back to Weather Extra. Last week, we talked about the increase in earthquake activity across West Texas and how some homeowners say they can't repair their homes fast enough as these quakes become persistent. Marvin Hurst traveled out west to hear how one local resident is ready to pack up and move on.
From above, Hermleigh is a Texas town paced with good old country peace. But on the ground, this home video shows Hermleigh getting rattled.
When you're in bed, it flat scares the bejesus out of you because the whole house just shakes. And it sounds like a bomb going off.
Dondeville has had a 155-acre spread in Hermleigh, not far from the Fisher County line, for 20 years. As much as he loves spending time with his horse and his dogs on their land, he says he wants out.
I mean, the earthquakes are getting bigger. They went from 1s to 2s to 3s to 4s. Now we're into 5s. What's going to happen when we get a 6?
The 69-year-old lives right next to the epicenter where a stretch of quakes has shaken that area for the past 2 weeks. Cell phone video shows the disarray inside of his home after one reached the magnitude of 5.1.
That was about 9-something in the morning. I had just sat down in my lazy boy to drink my morning juice after feeding my horse and stuff, and it turned the lazy boy over.
The shakeup does not stop there. A wall-mounted deer tilted, another one yanked out of the wall on the floor, books knocked over, shotgun shells everywhere. Through a window, a chair flipped, cracks in the wall. Inside of one of his closets, nails pushing through the ceiling. Then outside, a visible shift on the porch and splits on the side of his house.
You don't know what to do because you got that fear, but 10, 15 seconds is all you have. You don't have time to do anything.
We drove to his friend's home. Joe Hodge has cracks all around his home too, inside and outside. The fractures starting to add up.
I mean, it's every day, several of them, 4, 5, 6 a day.
DeVille is a retired railroad worker who first worked as a police officer, so he put his investigative skills to work. The green dots on his map are oil wells. The X is his home. The pinkish dots are saltwater disposal wells. He says 2 of them caught on fire. DeVille believes it's something about the working well's capacity that may be connected to earthquakes. Here's his map of the quakes from May to July of 2023.
The red ones are major. The green ones are the ones that we feel.
Now look at July 15th through the 30th of this year. Where you see the blue marks, you would not feel those events.
This is a man-made problem. This problem is made by the greed of man. I'm thoroughly convinced of that.
We spoke to the Texas Railroad Commission. They regulate these wells. They said in a statement that they are investigating earthquakes, quote, possibly caused by underground injection of produced water. Several operators in the area, they say, have converted deep saltwater disposal wells to shallow saltwater disposal wells within the last year. End quote. DeVille's home is a part of the 2.5-mile area under review. It's happening as he and his wife are ready to move on.
We've got this place for sale and had it for sale for several months. Who's going to buy it now?
In last week's episode of Degrees of Science, Brady Taylor had the chance to speak with the leading oil field related earthquake expert in Texas about the science behind why we're seeing these recent quakes in West Texas. If you'd like to hear their conversation, you could scan the QR code right here behind me. It'll take you directly to that interview on our YouTube page, where you can learn more about these earthquakes and the research being done to help prevent future ones. And coming up next on Weather Extra is this week's episode of Degrees of Science. There's been a lot of storm chasing buzz after the release of the movie Twisters this summer, and in this week's episode, we spoke with a team of scientists that are as close to the real-life version of what was in the movie. We'll learn more about their program, Doppler on Wheels, when we come back.
Welcome into this week's Degrees of Science. You know, with social media nowadays, you see all the crazy video of storm chasers getting close to storms and tornadoes. Well, this week we're talking about a group of scientists that get close to storms in order to get scientific observations, which are helping a lot of research when it comes to storms and tornadoes. Today we're talking with Dr. Josh Werman from the University of Illinois. He's executive director of the farm facility. So, Dr. Werman, I love all the acronyms that we can come up with in science. So what is FARM?
It's the flexible array of radars and mesonets. And that also lets us choose names for our new radars and things which sound like farm animals. So our newest radar is called the C-band on wheels, a cow. And we want to build a bigger radar that's going to be an S-band on wheels, a sow. So we're doing different types of animal names for our radars now.
I love all the names. So why is it important when you're trying to get the data to have, you know, mobile and quickly deploying style instruments like that?
We're trying to understand what's happening inside tornadoes, what's happening near the ground. We're trying to see the fine scale details. So there's really no better way to do that than to get instruments close up to the tornadoes, and in fact, sometimes even inside the tornadoes. So if we can get our radars on trucks, the Doppler on wheels, if we can get them close up to a tornado, say a mile away, then we can get data that is literally thousands of times better than you get much farther away. Sometimes I'll tell students that it's a difference between taking a picture across a parking lot and of your hand and looking close up at your hand. You can see your fingerprints when you're close up. From across the parking lot, no way. Maybe you can count the fingers. But if you want to see the fingerprints of the tornado, of how it's forming, of how it's doing damage, you need to be super close up. So that's why we're chasing them, but chasing them with a scientific purpose.
So a lot of chasers, you know, are trying to move around and position right. For you having a big group of vehicles and instruments and trying to place them, and very expensive, I'm sure, and stuff you don't want to damage, what all goes into work of trying to strategically plan where you need to be and moving everything around?
What we're doing is a very complex choreography. We're trying to get our multiple radars and other instruments in very precise positions so that we can measure specific things about those tornadoes. We don't just want a picture, we want radar data from different angles, from different ranges, at different levels in the storm. Similarly, we want cross sections through that storm with the instruments we deploy and hope get hit by the tornado right in front of them, combining that with the radar data.
This year you went on a storm that got a lot of national attention, the Greenfield, Iowa tornado. Tell us about the 300+ mile-per-hour wind y'all picked up in that storm.
We deployed very close to this town as the tornado was passing through the town and caused a lot of destruction there. It was fortunately very, very small, but it was extremely intense. We measured winds over 300 miles an hour, and that's among the highest winds we've ever measured. We actually have all the wind speed records because we're the ones who are measuring up close with the radars. That level of wind can pretty much destroy anything in its narrow path. This particular tornado only got rated EF4, most likely because there just weren't stronger objects in its path that it could destroy. One interesting thing about Greenfield is the tornado was dying as it was going through Greenfield. It was getting smaller, it was contracting to be very, very narrow tornado, and died shortly northeast of the town as another tornado formed just to its east, in fact, just about over us. But during that death process, it was intensifying. It was contracting and intensifying. So some of the worst winds were as the tornado was near death.
So all of this data, how much is this helping with it, whether modeling or trying to learn how tornadoes form? Is your data helping out with this?
When we go out with our radars and other instruments, we're focusing on two different goals. One is what we're talking about mostly with Greenfield. The other focus we have is how do the tornadoes form? Why do most mean-looking, threatening thunderstorms with rotations not make tornadoes? I mean, the false alarm rate for tornado warnings is huge because most of these threatening storms don't make tornadoes. Well, why? How can we make those predictions more precise so that we can reduce the number of warnings but maintain the accuracy, not miss any? And the second question, once we can start to answer that first question, there's a whole second set of questions we want to answer, which is, why do some tornadoes get so strong? Why do some tornadoes get large while others are small? Some tornadoes, as they die, just kind of dissipate and wither out. The Greenfield tornado did something entirely different and very dangerous. Are there ways to look at the environment that's around the tornado, look at how the existing conditions in the tornado, and make better understanding and make better predictions about why that happened and whether that's going to happen in a future tornado?
To hear more about the Doppler on Wheels program, scan the QR code on your screen to watch on YouTube or go to KWTX.com/degrees of science. Weather Extra returns after this. Welcome back to Weather Extra. Scientists have warned Western Norway could be hit by a devastating tsunami in the coming years. CNN's Michael Holmes has more on what could cause this.
It could be years or even decades from now, but geologists expect this mountainside will collapse into the waters below, triggering a tsunami within minutes and putting people in surrounding towns at risk. The mountainside lies near Xtra in Norway. For decades, the eastern side of the mountain has been undergoing gradual deterioration, losing up to 10 centimeters a year into the fjord below, according to experts.
It's a bit shifting. And we are, of course, a bit nervous when we see this changes in the mountain, because when it changes, there is something happening.
In 2016, Norway's Directorate for Civil Protection estimated that 54 million cubic metres of rock could fall from the mountainside, generating waves several metres high, which would crash into nearby villages. Two towns nestled at the end of the fjord may be hit with waves as high as 70 to 80 metres.
The wave will propagate in the fjord. No one knows how big it will be, whether it will be this size or that size, who knows? It can happen slowly or quickly. No one knows.
If a collapse happens, it won't be the first time. In 1934, a landslide of around 3 million cubic metres of rock happened a few towns over, triggering a devastating tsunami. That event inspired the creation of the movie The Wave, released in 2015.
We are not here for fun. This is real life. It's a large probability that we can have a large event which can create a major threat for the society. And we really need to monitor this, to have the control.
Sensors inside the mountain and instruments on the surface measure every movement of the mountain to sound the alarm in case of an emergency. Geologists say the mountainside will show warnings before plunging into the water below, giving nearby residents enough time to evacuate. Emergency plans are set, and when the time comes, authorities say they're prepared.
Concerning the life and the health of people, we feel rather safe, but it's clear that there are important material values at stake. From my point of view, I also think that having to evacuate thousands of people in a small area because of the risk of a landslide is a nightmare scenario for a mayor, I have to admit.
Experts are searching for ways to slow the mountain's deterioration, like draining water, which acts as a lubricant to the rocks. But these solutions are complex and costly, and some residents say it's best not to worry too much.
Here we are about 30 to 40 meters above sea level. It is certain that if the wave reaches 90 meters, we will be underwater. But we cannot live constantly with this idea in mind. Otherwise, we no longer live.
Michael Holmes, CNN.
Hopefully you were able to stay cool last week, but if you were hoping for a cool down this week, sadly there's no significant weather change heading our way, so continue to stay safe in this triple-digit heat. Well, that's all we have for you on this week's episode of Weather Extra. We'll see you again next weekend.